is Bruce LEFEBVRE.
Nicely done.
You should have heard me try to pronounce that at PhoneGap Day US. It did not go well. So he spoke earlier this year at PhoneGap Day US. He works at Adobe. Not on the PhoneGap team, but he works closely with us. He's a part of the long hair club, I like to call it, me and him. He did trim it down quite a bit since PhoneGap Day US, though, so I'm a little sad about that. He's going to be presenting about quantifiable performance. All right, you ready to go?
Ready to go. Excellent, thank you, Steve. So my topic today is, of course, quantifiable performance, which has since disappeared, and it's back. Excellent. So as Steve mentioned, my name is Bruce. I do work at Adobe. You can snap me on Instagram at Bruce LEFEBVRE. Please do reach out, though. I know we have a limited time to talk about performance here, but I will be here all day, so come and find me. It's a subject I'd love to talk about. I'm acting on the premise here that you are already doing some form of testing. I hope this is true. There's many types of testing you can be doing, of course. You can be doing testing at the unit level. You can be bringing those units together. You can do, of course, integration testing. You can test end-to-end your application. There may be some elements that are tricky to test in an automated way, so you may choose to do some level of manual verification as well. A piece of testing you may be overlooking, however, is testing the performance of your app in a quantifiable way. So this is a somewhat common occurrence. I hope it doesn't happen to you, but perhaps you can relate. Someone arrives at your desk, at your cubicle, leans on the edge and says something like, you know, the app is too webby, or it just doesn't feel like a native application. The appropriate response to that is, of course, you know, come on. So I'm always trying to get to the bottom of that and figure out what does someone actually mean when they say something like that, and how can we actually improve our application to make it feel more appy, for lack of a better word. Now, when we talk about web performance, there's typically two areas that we focus on, and this is in general terms. So we typically focus on page load, which is all about getting content on the screen as fast as possible. And this is, of course, still very important on the application side of things. You want to avoid things like this. You want to avoid spinners. You want to avoid blank screens. You want to give the user something, give them content right away, get them using your application as fast as possible. The second focus is always on runtime performance. And runtime performance is all about, once you have that content on the screen, your interactions with it should be silky smooth. You don't want to have any jank in your application. And what this means to have this silky smooth animations, and what we're talking about when we talk about jank, this is the focus of this talk, I should say. That's what I wanted to highlight here. We'll not focus too much on the page load. We'll focus on avoiding that jank. But what is jank? If you were to navigate to jankfree.org, an excellent resource, you would find the definition: any stuttering, juddering, or just plain halting that users see when a site or app isn't keeping up with the refresh rate. I managed to find a non-offensive definition on Urban Dictionary as well. Poor quality in relation to consumer products, and I think that's accurate as well. When something doesn't feel like it's performing well, it actually feels like it is a poor quality product. When we talk about refresh rate, whether we're playing Flappy Birds or whether we're texting, the device doesn't care. Your mobile screen is going to be refreshing at 60 hertz, which is roughly exactly translated to 60 frames per second. And this means that each frame has about 16.6 repeating milliseconds to construct each frame and present that frame to you on your screen, you or your users. So a quick anatomy of a frame. What goes into actually putting that content on the screen? In this case, we'll talk about a frame that was triggered by some JavaScript. So CSS animation may not have that piece of JavaScript there. First, the browser is going to go in and it'll have to recalculate style. So any styles that changed, it'll have to figure out which elements those apply to and actually recalculate everything based on the CSS, inline styles, and so on. Next, it's going to go about doing layout and actually laying out those elements on the screen, how they relate to one another, and how they actually all fit onto your mobile device. The browser is then actually going to put pixels into those shapes. And lastly, it will take those layers that it created during that process and actually composite. In the compositing phase, it'll actually put those layers together on the screen. This is kind of a perfect frame. Everything is happening within that 16.6 millisecond window, and we're achieving our 60 frame per second goal. But things can go wrong. For example, if you spend too long in any one of those phases, in particular, in this example, the layout phase, we're actually exceeding that frame budget of 16.6 milliseconds, and that frame is going to appear just as the last frame that was painted on the screen, so it'll appear that there was a dropped frame. This could also happen if the frame, or if the timer rather, that triggered that JavaScript is simply firing a little bit too late. So in this case, things are taking the right amount of time, but it just started a third of the way through that frame budget. We went over budget, and the frame was dropped. Thankfully, we have some tools that we can use, some free tools that we can use that can help us get past these performance issues, help us avoid these dropped frames. So in my app performance toolbox, you'll find a number of things. Number one, Carrie talked about this, your first line of defense against any performance issue is going to be your browser's DevTools. I am also partial to Chrome. Safari has some nice tools as well that you can actually use on to actually profile the device itself, which of course is going to be more accurate. There's also Appium and Chrome driver, which respectively allow you to automate your tests and actually issue those commands, how your app should behave, actually navigate through the application, find specific areas of the app, and run a test on those pieces. So test automation for iOS and Android. And they use the WebDriver protocol. So if you're already automating a site, you're probably familiar with this protocol. You can reuse that knowledge. And there's browser-perf. This is one of my new favorite tools. It's part of this toolbox. And this allows you to measure browser performance metrics, not just on device, but it does allow you to meter the performance of Cordova apps, which is why we're here. So a little bit about browser-perf. So it provides a Node API and a command line interface for running these browser performance tests that test specific actions. And when I talk about an action, I'm talking about things like actually scrolling the page from top to bottom, performing a specific animation, or perhaps animating transition between views. It allows you to test by virtue of Appium and Chrome driver on a variety of platforms and devices. And it collects a variety of metrics, which include the number of frames that were dropped, the mean time it took to actually prepare each frame, and the frames per second that you were able to achieve as a result. And of course, this can all be wired up through continuous integration. So if you have that ambitious developer who's checking things in and perhaps not running these performance tests, you would be notified that your frame budget was exceeded and the number of dropped frames has dramatically increased. You can see the exact commit that happened on. You can go and resolve it much faster. So I want to do a quick demo of how browser-perf actually looks and how it actually runs on real hardware. So I have my iPhone here. It looks like this is going to work. Excellent. And what I've done here is I have a repository that I'm sharing the link to. It's completely open source. It just shows a number of different scenarios with a fast and slow implementation for each. So I have this little browser performance app, and it shows how you could write an application that does scrolling in a very non-performant way, so very poor scrolling performance. If I flick that, you'll see it janking all over the place, and we can then compare that to how you might write some improvements and actually speed up the performance of a couple scenarios, and there's some animations as well. So if I wanted to use browser-perf to give me some metrics on how this application is performing, I'm going to go ahead and bump up the size of this terminal so you can see what's going on. But all I'm going to do is run a Node script that I've written that is going to, oh no. Oh, that's great. So I'm going to run a Node script. We don't really need that terminal. Node, I have a test directory. I'm targeting iOS, and I want to run my animation test So I'm going to run the fast. I'm testing the fast and slow. I've separated them, and I'll use the transform. So just a simple node test, or node script, rather. All the source is online. I'm going to share the link in a second. I'll hit enter. In the screen down below, I'm actually running Appium. So this is what's actually going to marshal those commands to my device. It's going to start up that application. In this case, it's going to do just a single tap. It's going to find a link element, the fast scrolling with the transform. It's going to tap that, and then it's going to go in and actually tap each one of these boxes, which will start the animation. Run the animation for 1 second, recording the metrics while it's doing that, and then it'll return me an array. And that array contains an object for every platform, every browser that was tested, in this case just iOS. And we can see metrics like the dropped frame count. 16 dropped frames, the mean frame time was 17 milliseconds, and we achieved 57 frames per second, so we did pretty well. And you can do that with the slow example and the fast example and compare them. So that's a very quick browser performance test, and of course this can be wired up with Grunt or with another tool by the same author, perf that actually uses a CouchDB database to collect your performance results for you and generate really nice graphs. So if you wanted to take this one step further, a fun little construction project, you can build yourself a little device wall with nothing more than a piece of plywood and a drill. It's a Velcro. And actually automate your test suite across a number of devices that you can proudly display in your cubicle. So I wanted to go into a couple examples of the performance sample that I put together and how the browser performance tests were able to prove out that the changes I was making to the app were leading to real improvements. So the first example I wanted to go over was that scrolling example. So you can see very chunky, things are halting, there's lots of jank on this page. And that is the URL, the short URL for this repository on GitHub if you want to check it out. So the first issue with this scrolling sample is we have absolutely massive images. This is just running in Chrome. If we zoom in on a couple aspects of this profile, we'll notice a few things. So Chrome is going to tell you right away. It's going to identify a lot of these problems for you. In this case, this frame took 922 milliseconds to render. That is well over our 16.6 millisecond budget, and we're hitting exactly 1 frame per second. So this is not good at all. If we scroll down a little bit further, we can see why that is. You'll find a couple of threads that are actually doing image decoding, so they're figuring out how we can fit these images onto this screen. In this case, the images are huge, so this image decoding is taking 370 milliseconds to complete, which is taking up the majority of that time. And there's a lot of images, so it's happening a number of times. Additionally, we're using JavaScript scrolling, and I am a massive fan of Ionic. The JavaScript scrolling, they've since released a blog post suggesting you use native scrolling. It was absolutely required a number of years ago, but native scrolling has gotten much, much better. So in this case, if you zero in on the script execution that's taking some time, you'll see that you can actually pinpoint the exact line in the code that is being called every frame. It's very, very fast, but you'll note that, I love this quote, what's better than JS animation, zero JS animation. So if you can avoid any JavaScript and rely on the native mechanisms on the device, that will usually be faster. So a few fixes for that slow scrolling. The images, this is an obvious one. Ideally, the images should not require resizing on the device. This may be unavoidable, but you can always get them down to the largest device that you wish to support. You can crop to fit the use case exactly. I work at Adobe. You can use Photoshop for this if you want, but you can actually just use some free tools as well. Use a tool like ImageOptim. This was going to remove a lot of the metadata and a lot of the things from that image, that extra bloat that adds size to the image that your users are never going to see. So you may as well clear that all out and save some bytes on the app, save some loading time. With JavaScript scrolling, again, avoid it if you can, but don't take my word for it. The Ionic folks released a blog post that I really liked on what their decision to go back to native scrolling in Ionic as the default. And styles, so you can use DevTools as well to find and fix these expensive styles, things that are taking a long time in that paint or layout phase. There's lots of links that I put at the end of the deck as well for the resources I use to find these fixes. And when I talk about the results, how we actually did, so with browser-perf, I was able to get, of course, those numbers that I showed earlier, and I was able to run the slow example and the fast example and get some actual quantifiable data. So by reducing the size of the images, there were 77% fewer dropped frames in my testing, and this was on a slower iPhone 4 device. We get a 42% frame per second increase as well, so huge gains from the images. With removing JavaScript scrolling, going back to native, we had a 3% frame per second increase as well. And by removing some costly styles, we were able to bump up our, have 13% fewer dropped frames. And I have all that data in a spreadsheet if you'd like to check it out too. So the second one, the last one, a quick one on that JavaScript animation example I showed. Again, animation is a little bit choppy. Let's see if we can make that better. So the issue number one I wanted to point out was the use of set interval. It may be tempting to think of your frame budget, 16 milliseconds, and think, if I want to do something once a frame, I'll simply set a timeout to run every 16 milliseconds. But this is going to lead you into dangerous territory, and luckily Chrome is going to point it out for you and make it glaringly obvious. But what you'll notice here, a couple of things. Number one, that bright red bar, that's obviously, Chrome is trying to tell you something there, lots of errors happening. And you'll notice the CPU usage is quite high as well. If we zero in on what's going on here, you'll see that that dotted line indicates the end of a frame. And you can see the JavaScript is happening while that frame is being essentially put onto the screen. So that is going to appear as a dropped frame. And that's simply because my animation timer is firing at an inopportune time. And it's happening without enough time for that frame to be generated, so there will be a dropped frame. You'll notice if you zoom in on those little red items in Chrome DevTools, Chrome is going to just tell you right away, forced reflow is likely a performance bottleneck. I had to Google what that meant as well. This is also called layout thrashing. And it's caused by back-to-back reads and then writes from the DOM. And what I mean by this, in a quick example, is that if I were to read something from the DOM, for example, I have my box document element, document object model, and I'm actually querying the style, the left property on that style. I do that, and then I write to the left property. So once I've done that, that's actually fine, but it's the following read. In this case, I'm now reading the top edge. So the browser is going to do essentially just-in-time layouting. So it's not going to compute that layout until it has to. In this case, it has to do it mid-frame, which is less than ideal. So it has to go in and say, OK, you moved to the left, so now I have to figure out where the top is and return you the number for that. And Chrome will point this out and make this very obvious to you in DevTools. And the fix in this case is just to either do your reads first, or even better, just compute those values so you're not reading from the DOM at all. In this case, I'm just moving a box with a speed of x and y, so I can simply calculate where that element is. So a few fixes to see how we did. Number one, instead of set timeout, try request animation frame. And you can replace almost exactly. I've got a code sample here to see how that would look. So your set interval rather, if you have it set to fire once every 16 milliseconds, don't do that. Instead, what you want to do is create a little function, call request animation frame. You never pass the timeout. It only fires once, so you have to actually call it again, so it recalls itself at the end of that frame, and that will actually fire at the right time. It won't fire while the frame is trying to be printed to the screen. And this achieves the same effect as the above, but it actually meets the refresh rate of the device it's running on. Avoid that layout thrashing, so avoid that querying and invalidating those styles in a back-to-back way. And if you can, use a property that the browser can animate in a cheap way. And what I mean by that, when I say compositing is cheap, I took this image from High Performance Animations. I really like how this breaks things down. There are some very expensive styles to animate, and there are some cheap ones. And the cheapest ones happen at the end of that waterfall in the compositing phase. And those are things like transforming and changing the opacity of an element. So if you can, do all your animations in that compositing phase. you'll notice things like top and left are further up. So they're going to actually require a layout and a paint step as well, not just moving a layer or changing the opacity of a layer. This is what happens in the compositing phase. How did we do? With request animation frame, we had 51% fewer dropped frames. By avoiding layout thrashing, rewriting our code a bit, 20% fewer dropped frames, and with translate 3D, we had a 2% frame per second increase as well. So big gains that you can have, and I find it so cool that you can actually meter those gains, see your improvement over time. So I'm going to close with a little challenge for you, if you choose to accept it. We have, there's this app-perf sample that is on GitHub. If you can clone this sample, there's a few dependencies you have to install and run. You likely have a number of them already as PhoneGap Day attendees. You can replace the www directory with your own application and quickly test the scrolling performance, which is a pretty, will give you a nice overview of your app, if it does indeed scroll, by simply running this this node test, and I've tried to comment that file as well to give you a few pointers on things you might want to change if you don't have the iOS 9.3 simulator on your machine. So that is my challenge to you, and with that, thank you so much for your attention. Enjoy the rest of PhoneGap Day.
Oh, that was awesome. Great talk. Got to check out that sample.